All right, in this video, we're going to talk about matrix multiplication. I'm going to do an example with this problem here, and then try and explain how it applied to different size matrix. So the first thing we have to check when we're multiplying matrices is we need to look at their dimensions or their size. So dimensions are always going to be rows by columns. So this first one has 2 rows and 2 columns, so we call that a 2 by 2. So again, this is row, column. The next one is also the same size, 2 rows, 2 columns. So it's also a 2 by 2. Again, row is first, column is second. Now, in order to be able to multiply matrices together, their inside dimensions, so that's the column on the first one, must match the number of rows on the second one. If those two match, you're good to go. If those are not the same number, we cannot multiply them at all. And then the answer is going to be one with 2 rows and 2 columns. Okay, so our answer should be a 2 by 2 when we are all done. Okay, so now we know what we're going for. We know at the end of our problem is going to be a 2 by 2. So we're going to start now by looking at the left matrix, and we're going to look at these rows, and we're going to match them up with the column on the second one. That's why these internal numbers need to match up. So we're going to multiply the 0 and the 6 together, and we're going to multiply the 2 and the 3 together, and then we're going to add them up, and that's going to be row 1, column 1 of our answer. So let's go ahead and write that down. So row 1, column 1, we're going to do 0 times 6. I know that's just 0, but I'm going to write it all down in its entirety. Plus 2 times 3. So all of that together is row 1, column 1. And then we're going to do it again for all the other ones. So now we're going to take row 1 and multiply it by column 2. That's going to be row 1, column 2's answer. That's the one on the right here. So we're going to do 0 times negative 6 plus 2 times 0. Okay, so we're done. So we multiplied row 1 by column 1, and we did row 1 by column 2. Now we're going to go to row 2. So those are going to be the answers here in row 2. So we're going to take this whole row, show you in a different color. So now we're going to take row 2, and we're going to line it up again with column 1. That's going to give us our answer for row 2, column 1. So negative 2 gets multiplied by 6, and negative 5 gets multiplied by 3. Okay, so let's write that down all completely out, and then we'll simplify at the end. So it'll be negative 2 times 6 plus negative 5 times 3. And then we're going to do the same thing now with column 2. So negative 2 times negative 6 plus negative 5 times 0. And again, that was row 2, column 2, so that goes into row 2, column 2 of the answer. So knowing what number row and what number column you're multiplying by gives you that location of where you're working in your answer matrix. Okay, so now let's just finish off our problem. I'm going to quickly simplify these. This is 0 and 6. So that's going to give us an answer of just 6 for row 1, column 1. And then we've got, this is 0 and 0. So that's just 0. And then we've got, let's see, this looks like this is going to be negative 12 plus 15. So that's going to be positive 3. And then we've got, let's see, positive 12, and that's just 0, so 12. And that is our final answer for our matrix. Okay, let's back that up a little bit. Actually, we'll do that whole last piece. Okay, so let's go ahead and go to our answer. Let's simplify them as we go. So 0 times 6 is 0. And then 2 times 3 is 6. So that's going to be 6 for row 1, column 1. And then we're going to go to the next one. We've got 0 times negative 6 is 0. And 2 times 0 is 0. That's just 0. So that's row 1, column 2. And then below we've got negative 12, and then I believe that's just a times 3, so that's going to be minus 15. So that simplifies to negative 27. And then this one's going to be negative 12, no, positive 12, excuse me. And then that's just 0, so that's just 12. And that is our final answer. As you can see, we've got 2 rows, 2 columns. It's a 2 by 2 matrix. So that matched what we talked about and what we predicted at the very beginning of our problem.